So welcome to our week 3 live lecture. Today is the 24th of June. For those of you that are watching us in the recording, or if you're here joining us live, I just want to welcome everybody to the session tonight. And again, I just want to say great job in weeks 1 and 2 so far. I understand, and I've had personal conversations with several of you that I completely understand how challenging programming can be, and I think that you're just doing a great job. I know you're working hard and getting a lot of great stuff done, so I do want to appreciate your hard work. And we are going to look at a short PowerPoint. I just want to introduce the topic for this week, and then again we will have the opportunity to, at the end of the session, we're going to make sure that we go through a few assignments as well, because this week so far is probably going to be the hardest topic that we've seen so far. It's not terrible, but it's definitely, like I say, a little bit harder than the material that we've covered so far. So nothing to be too concerned about. Hey Matt, how are you doing? Okay, so as we get into the session, I'm just going to mute everybody in the beginning. And then, like I say, as we get towards the end of the session, we'll have a time to work through assignments and ask questions as well. So again, welcome to week 3. Just a little bit of quick housekeeping from the previous weeks. And everybody can see my screen, right? I muted everybody. Mark, can you see my screen?
Yeah, I can see it.
Okay, perfect. Okay, so just a few takeaways from week 2. Again, great job to everybody. I will tell you that if you have missed anything up to this point, make sure that you are in communication with me. I do want to make sure as we move forward, the material is obviously going to get a little bit harder. So I want to make sure that you're building those strong foundations in the initial material, because we want to make sure that as you go forward, you have all the tools necessary to set you up for success. So again, please reach out. If you have questions, you can text me, email me, phone me, however it's more convenient for you. For this week, I will recommend again to start early. And obviously, if you're watching this video either live or if you're watching the recording, I applaud that, because like I say, we are going to go through some of the fundamentals tonight. The videos in the guided practices for this entire week, at the very top of the instructions, we've placed those Pluralsight videos, which I did send out a text message to everybody, and hopefully you also got an email with the instructions. But I encourage you to watch those videos. They're really short. They're not going to take you too long. But at least for me, I'm really a very visual learner. So if something is presented to me in a video format, that's one of the best ways that I learn. And everybody has a different learning style. If that's not your style of learning, that's understandable. But they're a great resource. So they are in all of the guided practices. Before you can watch them, you do have to create the account, which everybody in the class has an active account. You just have to activate it. So I would recommend to do that. And then, of course, again, make sure that you are checking the assignment submissions in the classroom itself, because those are going to be towards the bottom of the instructions, but they very specifically tell you what is required for the assignment. So, for example, is it a Word document? Is it a .c file and a Word document? Is it a Flowgorithms file? So just make sure that you're keeping abreast of that so you know exactly what's required. And then one thing I will touch on, and in everybody's assignments as I go through them, one thing that I encourage students to always include is comments in your code. And we've spoken, many of you, and I have spoken with you one-on-one, and the reasoning behind comments is this. There's many reasons, but as a programmer, as you develop code, remember your code can be very complex, very long. And for example, say we are on a team, the 4 of us on this call are on a team, and we all are responsible for different components of the code. The easiest way to communicate is for us to leave comments for each other. Hey, Matt, I didn't know how to do the function for this particular area. Can you take a look at it? I wasn't able to complete this, Mark. Can you help me out with this? Paul, I know you're coming on later tonight. This is where I left off. Can you finish off? That's one way for comments. In our particular environment, comments are great because they're going to allow you to expand on what the code is doing. So they don't have to be very complicated, don't have to be very long, but just, again, try to include those as much as possible. And then, of course, a quick reminder, the main post will be due this coming Thursday night before 11:59. Again, we can take a look at the discussion tonight. It is a coding discussion once again, as we saw last week. And this is a function discussion. So for this week, you're asked not to delete anything, but you're going to add functionality to the program that already exists. So again, we can take a look at it. Once we get the gist of functions, I think you'll be able to move through them pretty quickly, but just initially they can be a little bit confusing. So what to expect for this week? This week is going to be all about functions. And a very simple way to explain a function is this. In our previous weeks, we have seen programs where all of the functionality, all of the processes, all of the procedures take place in that main program. So we'll have include studio.h, the initial header initialization. We have int main and our curly brackets. And again, within those curly brackets, that's where everything has taken place. We define our variables. We ask the user for input. We save it. In the previous programs, we've done some calculations. We've seen looping structures. We've seen decisional statements. But again, everything has taken place in that main program. That's not a bad way to write code. But again, in general, the code that we have seen has been fairly elementary in terms of length. In this class, I don't believe we've seen anything more than 50 lines of code, which I think that's even a stretch. So we haven't truly gotten to experience what programs are like. And to be honest with you, programs tend to be extremely large, thousands and thousands of lines worth of code. So when you're looking at a program that is so complex and so long, is there a way to maybe simplify it? Is there a way to take some of that functionality out of that main program? And that's what we're going to explore this week. So an example that is in the class that I really liked was a word processing program, which everybody in university has probably used. Most of us use Word. If you have a Mac, they have their own version of Word, but a word processing environment. The capabilities of that program, they are vast. They can do many, many things: spell check, document templates, colors, fonts, etc. When we look at this, again, the programs are very large in terms of what is required to get that program to function. So what programmers have done to simplify that process as much as possible is to create what we generally refer to as a module. Each module then, for example, has its own specific task. It has one thing in life to do. That's what it does. Just like, I don't know if anybody knows about soldier flies. I'm a composter, so I'm going to give you an example. A soldier fly lives and breathes to create the next soldier fly. That's the only task in this world. A module, its function, whatever that function is, that's the only function it has. So if we go back to the Word example, spell check. If a function is its job is to do spell check, that's all it's going to do. If the function is to do fonts and sizes and colors, that's the only thing it's going to do. So again, we now remove that from the main program. We separate it into its own function to create not necessarily a shorter code, but it is going to create a little bit more of a simplified code. So different languages, you'll see this term interchangeably. Sometimes we'll refer to them as a module. Typically in the C language, we will refer to a module as a function. It's the same thing. If you see it in the class referred to as a module or a function, don't be alarmed. It's really going to just be the same thing. So in week 3, we'll look really at 2 types of functions, the ones that we define, which are called programmer defined, and then there are also prepackaged ones. Honestly, the ones that we are going to focus on more are the ones that you as the programmer are going to write. So we'll give you the tools and understanding to be able to do that. And then we're going to see how these functions, again, work together. Even though the functions are outside of the main program, it's one interchangeable program. They function together to create the desired outcome. So some benefits, like we've spoken about just briefly, you are allowing the program to be divided into smaller portions. Again, many of you, we've had conversations about programs, right? for example, a looping structure, rather than you writing 100 printfs, you write a few lines of codes that takes care of all of those printfs. What does that do for the program? It allows you to simplify it. And quite frankly, I've always been told that the simpler the program, the less opportunity there are for errors. So again, if we divide them into these smaller portions, if there is an issue with one of the functions, it's a lot easier to identify the issue in the function versus 6,000 lines of code. So again, just streamlining that process. And the other thing is that you can call the function whenever you need it. So that's a little bit of flexibility. So visually, let's just take a quick look at an example. And then, like I say, once we're done in the PowerPoint presentation, we're going to get into the nuts and bolts. We're going to get into Flogorithm. Quite frankly, I'm going to tell you, I think Flogorithm is harder to write functions initially than Dev++, just because of not knowing necessarily where all the environments go. So we'll work through all of that tonight so that you know how to do that. But let's take a look. This is in the online debugger that I have referenced on a few occasions, but this is an example of a program that we've actually seen in some form or fashion within the classroom. The overall concept of the program is that we have a number that we've defined on line 7. We ask the user to enter a number. We save it on line 10. Now, if you look at line 12, we have a printf statement, and it says the number cubed is, and then we reference the cube variable. However, if you notice the functionality of that outcome, the process or the equation that is determining the outcome of what that number is going to be cubed is not housed in the main program. If you look at line 3, int cube, open brackets, int y, semicolon, that is really the introduction of the function. The function processes are not done at that moment. They're done starting on line 17 downwards. Once the result is determined, we then feed that result back into the main program. So it's almost as though you ask the user for the number, they enter the number. At this moment, we go out of the main program into the function. The function does the calculation, determines what that number is going to be cubed. It feeds the result back into line 12 and outputs the result. Now, this is all very seamless. It seems as though it would be a very complicated process, but it's done within a matter of seconds, just like we've seen in the other programs. But again, the point is this, that outcome of that number being cubed, so number times number times number, as we've seen in our previous programs, was never done in that main program. It was done outside of the main program. So again, not a very complex thing. The biggest challenges is navigating how do we introduce the functions, what is going to be placed in the function, and then bringing the result back into the main program. But that is a very simple example that, again, we've seen where the cube is actually done within the main program. So I thought that would be a good example for us just to kind of dive into the material. Again, just some tips and suggestions. This week, I will be doing the study group on Wednesday night at 7. And then I also have an open office hour during the day. So everybody's more than welcome to attend those. And then, of course, next week, we are going into the break, July the 1st through the 8th. So I'll be sending out some notifications just as far as the schedule and, you know, how to handle that time off to be able to make sure that we are going to be successful. Okay. So let's get out of the PowerPoint for a second. And before we move on to the exercises, does anybody have questions at this time? I know we have Mark, Paul, and Matt, and you can also type in the chat if you do have any questions.
Not at the moment. I got to apologize. We're having some issues over here. That's why we keep blinking in and out, but I think we've resolved it since.
Oh, no, you're fine. Don't worry about it. Matt, I think everybody's having some storms tonight, so
yeah,
no worries at all. That's what I tell people, you know, technology, I think technology teaches us many life skills. We have to learn to be creative. We have to learn to be problem solvers. We have to learn to be patient.
And make sure your equipment's working before you sign on to a Zoom.
Oh, it's the thought that counts. At least you try to make it.
Right.
Okay, so can everybody see my screen?
Yes.
Okay. So we're going to look at a guided practice for tonight. I'm going to work through both the Flowgorithm and the Dev++. And again, if you're watching this live or if you are watching the recording, it is very important to make sure that you follow the steps that are required, because what happens with the flowchart especially, what I have seen is that a lot more students struggle with the flowchart aspect because sometimes of how it looks. I'm going to do the first one with you, and then I'm going to skip out into another one. There's one guided practice where it shows functions on the screen in your instructions, and the functions are shown in all one page. However, in the Flowgorithm program, it's not actually designed to house it like that. So I just want to walk through that so that you understand. These are the videos that I had mentioned earlier. So again, you will need to have your Pluralsight account active and activated. And then once you do have that information, you can watch these videos. Again, they're not very long at all, 41 seconds and then about 3 minutes. So nothing too long. But again, if that is your style of learning, if you do enjoy the visual aspect, that will be a really good opportunity for you. And I think we have a chat, so let me make sure I look at that. Can you put the other C program? Yep. So we can take a look at that, Mark. Let's work through just a few of these, and then we can go back to the stuff that we looked at yesterday. That's no problem at all. Okay, so for this week, this is our first really introduction outside of the discussion to a function. It's pretty simple. Let's look at the overall picture, and then we'll actually get to program it. So it tells us that we are having a function demo. There's first function, second function, and then that printf statement, we are going to have that print from the main program, main ending. We then have these definitions of our functions, right? So up top, line 3, we have first function. Line 4, we have second function. And then underneath, we have the first and second function in action. This is where they are defined, and this is where they're doing their job. The job of the first function is simply to print out the words printing from first function. Technically, that is not actually printed at that moment. It is sent back to the main program where line 8 references it and prints it out for us. The same is going to be true of the second function. So you'll see this program is written a little bit differently in terms of first function is not defined as anything. It's not defined as a void or an int. I'm going to tell you, I've written this program a few ways. And for example, for line 3, I have written it with int first function, int second function, and it has run just fine. Sometimes some of your programs I know give you a little bit of glitches when it comes to that. So if that is the case, again, we'll work around it. But the main point for this week, again, is to focus on those functions. This will be the outcome that we're looking for. So we're going to print the function demo. We're going to get these called from our first and second function. So we'll get that from line 16, pushed through back into the main program. Same is true for the second function. And then again, this is done also in the main program. So again, not very complicated. We could achieve all of this in our main program, but it just gives us examples of how we can start to push some of that functionality away from the main program to keep it a little bit short, a little bit concise, and allow these functions to actually do their job. Now let's look at the Flowgorithm. Okay, good. This does show it, because again, this is a little bit confusing. So the flowchart, this part right here is our main program, where we have the function demo that is printed. We then call the first function, the second function, and we do an output main ending, and then we end. So now on the screen, it shows us that this all looks like it's going to be on that one main page in Flowgorithm, which it's not. So we'll get to go take a look at that today. Those are separated into their own. It's almost like an Excel worksheet where you have the main worksheet, and then you have tabs that are going to take you over to those other ones. So now that we've seen what it looks like in the classroom, I'm going to get into Flowgorithm. And I was playing around with it. So let me do a new window. I'm going to share my screen and just let me know when you can see it.
It's up.
Okay, perfect. Okay, so we have our main program, which we've seen many times at this point. We kind of are familiar with just the general processes with Flowgorithms. So we are going to go ahead and insert, again, what we have been given in the instructions. So the first thing it asks us to do is to insert a output window. So we'll right-click on the arrow, select the output, and the output asks us to type in function demo. Now, I know some of you are pretty creative. I've gotten some pretty amazing programs. You add your own little flair to the program, which I'm perfectly fine with. Again, as long as the overall premise of the program has been met and the instructions have been, you know, gone along with. If you change the words up a little bit and you, again, add your own little creative flair, that's perfectly fine. For today, I'm just going to stick to what is in the instructions, though. So function demo. Okay. Now, the next thing that it asks us to do is to introduce the function call within that main program. So I'm going to right-click on the arrow again, and underneath, let me move my little window here. Underneath the control section, you'll see this rectangle that says call. That's how you introduce the function within the main program. There's a different step that we have to take to actually introduce a function, but this is how we're going to show it in the main program. So let's click on that. They have told us to call it first function where the second F is uppercase. So I'm going to open it up. And for this, again, this goes back to the previous weeks where we're not going to do any quotations at this point, nothing outside of the name that we need to associate it with, which is going to be first function. As we now, in a few seconds, introduce the function itself, the names have to match identically, and we'll talk about that when we get to that step. So once we have first function typed out, we're going to click OK. Now we are asked to introduce a second function that is going to be called second function. Spaces. Again, this is very similar to almost the variable declarations where we're calling them by their name, one word, and there it shows up in our window. And then the last thing that is going to be dealt with in the main is the output print statement, which we are going to say main ending. And that was it. So again, keeping the main program pretty much as simple as possible. Now, in order for us to now work on this second function, remember in the classroom itself, it showed you the main function. Right underneath it, it showed you the first function. In Flowgorithm, that is not an accurate representation because I cannot, below this program in this little window down here, introduce that function. That was simply how it was copied and pasted into the window. In order for you to achieve that, we are going to work in this window right here where it says main and there's a little drop-down arrow. This drop-down arrow right now just says main because we haven't introduced any additional functions. But as this grows, this menu is going to change for us. And this is where we're going to see those different options. So at this point, now we want to actually introduce the function. This is where we're going to start the process of taking out that print function from the main and putting it in the separate function. To do that, if you'll see these two little purple bubbles to the right of the drop-down menu, we need to click on this. It's called the function manager. So let's click on that. And we are now going to add a new function to our program. So you'll see that there's an empty window here. We have an add button, an edit button, and a done button. Initially, the first thing we have to do is click on add. And it's going to ask us for the function name. So again, the first one that we created was called first function. Parameters at this point, we don't have any. I will go over a second program tonight to show you what the parameters are referring to. The return type and the return variable, we're not going to play around with them in this example. All we're going to do is click OK once we have that first function named. And again, this has to be identical to what was listed in that main program, which at this point, I'm just following the instructions, but it has to be identical in terms of first function, uppercase F for this second word. And once you've done that, you'll see that this shows up in our window. I'm just going to click on Done. And now you'll see that I've come to a new window. If you click on your down arrow, you'll see now I have my main, which I already created, and I have my first function. So again, according to the instructions, this function, the only thing I need to do is now include a print statement. So that will be an output. And the output statement is going to say, printing from first function. And I'm going to click OK. So again, this example really gives us a great introduction to the idea of functions and how they intertwine. That you have your main program, and then the way that I explain it is that you have a main program and almost mini programs. The mini programs have their own responsibilities, but they do work together as a unit. They just have their own things that they're going to be doing. Okay, so now let's look at the second one, the second function. So we're going to go through the exact same procedure. We're going to click on the bubbles, the little purple bubbles function manager to the right. That will show us the first function. So we already have that one created. Let's click to the right where we say add. This one, function name, again, based on the instructions, is going to be second function. Again, at this point, there are no parameters. I will come back and show you what the parameters are going to look like, because that, again, is a little bit confusing. So I just want to make sure that everybody is on track to know how to handle that. Then we'll click OK, and then we'll click Done. So again, now if you come back to your drop-down menu, you'll see you have main. Nothing has changed in the main. My functions that I initially introduced are still there, and they should match identically to the names here. I will give you a warning if your first function called in the main program differs at all from these, the program won't function properly. Because remember, we've spoken about this before, programming is all about that consistency, just like your variables. If you call a value at the top of your program and you then reference the variable as number, remember there's that lack of consistency. Same thing here, first function, second function have to be called, written, spelled exactly the same way. So let's click on second function, and we're going to do the exact same thing. So we're going to do an output statement, and according to the instructions, we are going to say printing from second function, and then we're going to click OK. So I'm going to run it. I don't know if you'll be able to see it, but we're going to run it. The only thing this program is going to do is print out function demo, printing from first, printing from second, main ending. So it's going to be a simple thing. But again, even though we won't see the inner workings, the main program is going to call to that first, pull out the print statement, call to the second, print out it, and then come back to the main. So let's go run, and I think you probably can't see that, so I'm going to do a new share. And that way you can see the outcome. Okay, and let me know if you can see that output screen.
Yes, we can see it.
Perfect. So again, if we based it on the lines of our code, it printed off that first printf, bounced off to the first function, pulled that printf and printed it out, bounced to the second, printed that out, and then came back to the main. Again, completely unbeknownst to the user, right? And that's what I constantly remind students of. You as the programmer are like a mechanic. You are going to go into that garage, and you are going to determine what is going to be the most applicable, the best print programming scenario for the situation at hand. But this is a great way to write your programs to keep them simple. But again, obviously the user will never know. So before we move on to the Dev++ portion, what questions do we have, if any, at this point as far as functions go? Any assignment questions we can hold off until the end, because that way we can actually get into the nuts and bolts for them. But any questions based on what you've seen so far? I know it's new, so you may get questions later on, which is fine too. But I just want to make sure at this point if there's any questions. And Paul, I know if you want to put them in the chat, that's okay as well.
Nothing on this end. I can't speak for. Is it Paul with us today? I see Wade B. I'm not sure who.
That's Paul, yeah.
Okay. All right. No, nothing on my side.
Okay, perfect. Okay, so I'm going to stop sharing, and I'm actually going to program today in the online environment. Set up a little bit today. And I'm just opening it up, and then I'm going to get back into the class so that I can get into the code itself. Okay. And let me know when you can see my screen.
We can see it.
Okay, so again, this is our online debugger, and I encourage students, again, if you've worked with me one-on-one or in the study groups, we have many debuggers that we can use. The Dev++ is great. I use that frequently. We've used Visual Studio in the past. This is another great one. If you are getting into software development, there's nothing wrong with working in different environments. I particularly like this online one just because it's a quick debugger. But also, if any of my software is giving me any glitches and I'm pretty confident that my code is working, I like to double check my work in this environment. So it's a good tool to have. Somebody told me this, you can have debuggers as an app on your phone now. So if you're that way inclined and you want to be at your kids' soccer games and debugging your code, I say that's a great thing. So let's write this code and we'll see how it's going to be performing. So we'll start with our Qt Studio. And again, it's going to be initially, obviously, a lot of the stuff that we have seen before. Now, this is a little bit different to what we have seen in the past, right? Because initially we go from the header declaration into our main. So now we have to do the declaration of our functions first. The function will be declared at the top, and then we're going to come into the processes of that function outside of the main. So they almost are, it's almost like a main program sandwich. You have the function, main program in the middle. And again, this is directly out of the instructions. So we've done our first two program or our first two function declarations. Now we're going to come into the main. And I will play around a little bit once we've gotten the program to work because, like I say, many students, obviously, we have become very accustomed to defining variables or our processes with int first function. So we'll leave it as it is in the instructions and then we'll come back and play a little bit at the end. So in the int main, we are going to define our curly brackets first. So we're going to have our printf statement where we have function demo. Then we're going to don't forget my semicolon. Okay. Then we're going to have the inclusion of the functions. You'll see that they do have to be identical to what we have on lines 3 and 4. That's not always going to be the case. Sometimes you will have to have, for example, integers, etc., that are going to be introduced. So that will be different depending on the program that you are writing. We have second function. We have printf again. We have main ending. And then we have the return statement. Okay, so again, a relatively simple main program where we are defining our functions outside of the main. We then come into the main program, we have a printf statement, just like we saw in our Flogarhythm, where we will have a statement that prints function demo. We now reference our functions, first and second, which we are now going to design and create outside of this main program. But this, what I explain to students as far as how you connect your programs, think about this statement right here as your bridge. This is the connection between your main program and the function itself. You have to have that bridge where they can communicate. And this is the line that does the communication for us. We then end the program with the printf statement saying main ending. So that's it. Again, a very, very simplistic main program. But now let's get out of the main and we're going to design our function. So first function, what you'll notice, which is very important, look at the syntax required to introduce the function versus where we actually now create the parameters for the function. They're identical, however, there's no semicolon at the end here. And this goes back to what we've seen in our if-else statements, our while statements. At this point, you're introducing the idea. Here, you're introducing the process itself. So you're not stopping the thought with the semicolon. You are just showing this is the beginning. Now we have to get into the printf or the functionality in this case. So we have a curly bracket. We're going to do a printf statement. And it's going to say printing from first function. And just like we have seen in every single printf that we have written, they are written even though they're not in that main program. They're written exactly the same. Printf, round brackets, semicolon at the end, and then that statement is going to be within quotations. Now we'll create our second function. And again, exactly the same thing. We're not going to have a semicolon at the end because this is not the end of the idea. Now we're just introducing the actual processes for the second function. We're going to do pretty much the exact same thing. Printf, round brackets, quotations, printing from second function, semicolon, and then return. Okay. So that really was the entire program. Now let's see how it's going to run. Okay. So you'll see that the program ran perfectly, but let's go back and clean it up a little bit, right? Based on how we want it to look on the screen. So we'll add a little bit of \n to each of the sections. And I'm actually going to put one at the beginning here. And remember, this is strictly on how you want your program to look, how you want your user to be able to experience the code that you are writing. I would say there's really no right or wrong when it comes to how you want your code to look, but the neater you make your code look, obviously it will be a better experience for the user. Okay, so let's run it again. So they're a little bit cleaner. Function demo, printing from first function, printing from second function, and then main ending. So again, the main program itself was responsible for what? It was responsible for printing this function, printing this main. However, these two statements here, it never printed it itself. What it did was it created a bridge between the main program and the function, and it pulled this statement right here and printed it to the screen. Again, the user had no idea what was happening, but in the back part, we created a main program that was responsible for simply printing two statements, and then it referenced the functions to be able to pull those additional informations. So again, a relatively simple program, but it's not a simple concept. So I wanted to make sure that we at least covered one entire Flowgorithm and then one entire program. And then I am going to get into one other thing in terms of parameters. But before I touch on that, any questions from this assignment, any concerns, any things you want me to maybe clarify for you before we move on to that second part?
I'm good. I don't know about Paul. I can't speak for him.
Okay. Paul, and again, you can chat in case you did have any questions. And I want to get back into the class. There was one question I know that we touched on last week, Paul, in terms of adding parameters, because sometimes you're going to see in your functions in the flow chart that there are the function name, and then next to the function name, there are a set of brackets, and then there's words within the brackets. So I just want to address that also while I'm recording.
Can you hear me, Lisa?
I can hear you, Paul. How are you feeling?
Well, I'm a little sore, but I do have a question.
Okay.
How do you integrate a third function?
That's a good question. You would just do the exact same thing, Paul. So how we did, for example, we defined first function, second function. You would at the top put third function. And let me share my screen and then I'll actually show you.
Yes.
I do know, I think that's one of the assignments where you are asked to introduce a third function. Okay, so let me know if you can see my screen.
Yes.
Okay.
See, you go to line 5, you're going to introduce the third function right there.
Yep, I would do third function.
Uh-huh. And now, as far as the printing after the main, I want you to say instead of say function demo, yeah, you put that one in there, but on the printing part. Okay, go ahead.
The printing, it would depend on the requirements of the program, right? If we simply were adding a third function, remember, so this touches on the discussion, because in the discussion, I believe you are given the function of addition. In the main program, you ask your user for a number, then you ask for a second number, and then it prints out the result of those two numbers added together. Outside of the main program, you have an addition function that does the calculation for you, feeds the result back in, and then you print out the result. The program then asks you to add a function. So you're not going to remove the addition, but maybe you'll include multiplication, maybe you'll include division, subtraction. The key for that assignment, and we'll take a look at it tonight, but the key for that is, where do you add, when you're adding a function, what all do you need to do to make sure that you're including everything? There's three things. You have to add it at the top. You have to introduce the function.
Yeah.
You have to include it in the main program.
Yeah.
And then you have to create the function outside.
You create a third function right there. Got your breakfast and all. Yeah.
I would do the exact same thing.
Okay. Now, as far on the like in line 12 up, right there, like between 9 and 13. The first, especially on number 9, is the print. And you want to say only you're going to print, so the user is just going to see first, second, and third.
Yeah.
And number 9, instead of a function, you write just first.
So in that case, I would not do that. And the reason I wouldn't do that is because now you're encroaching on what the function is supposed to do. So you could take this out completely and not have any type of function printouts in terms of function demo. But if I introduce a print statement in my main program for printing the first function, then the question is, why do I have that first function in the first place?
Right. But and then still we're going to the bottom and add the third function, like in line 25 or whatever it is, right? It's still.
Yeah. So
Okay.
I'm just going to copy and paste it.
Yeah.
And then I would just say printing from third function.
Okay, I see. Okay, because I tried to do something like that and I ran out of trouble. Now, as far as the discussion, I did multiplication and the thing it gave me 0 errors, but still concerned. I mean, still I was able to run it, but I'm not sure I did it correctly, you know. So I still like I got 0 errors. I was able to get the execute file and all that, and but I'm not sure 100%. And also, as far as the logarithm, the flow chart, I did it, but I'm not sure because maybe I missed the step that you just showed a little while ago, you know, on that.
Okay. And when I stop sharing today, Paul, we can take a look at your discussion code and I can kind of look through it and see maybe if there's something missing. But remember, the good thing with the code, the first thing we always look for are syntax errors because that's the biggie. If you're not getting the outcome, that's maybe a logical thing. So I can take a look and kind of walk you through that.
Yeah, I just erased some lines and added some more information, you know, and replaced it with multiplication. I call it M equal multiplication. And I cannot remember what I did. I had to, that was it this morning that I did it. And right now I have anesthesia in my head, so I can't remember.
Yeah. The biggest thing that I see students struggling with the discussion is that they, for example, it's something like this, right? Int add
Yes.
int x comma int y.
Okay. As far as that, you know, on the bottom we have something that said return. I did return. I did it two ways. I did it like kind of copy the old one somehow, and I did return x times y.
Okay.
And then I replaced it and I ran it, so it ran fine. And then I was playing with it and I replaced the X and Y for A and B. You know, it still ran okay, you know, so, but you will see it later when we go.
Okay, perfect. Okay, so let's just take a quick look at this one other thing in Flowgorithm. And I'm going to pull up the same assignment that I had earlier because I'm just going to use that as the foundation. And this assignment is going to be, it's Unit 3 Guided Practice 2. So in this one, I'm not going to share the screen, but you'll see that one of the, well, actually I will share it just so that you can see what I'm talking about. Again, I'm more visual, so if I see it, maybe it will make more sense to you as well.
That's a practice one you said?
Yeah, it's the Guided Practice 2.
2.
So look at this. It says first function and then brackets counter. That for students is very confusing. So I want to show you how to do that in Flowgorithm.
Yeah, I had a trouble with that one.
Yeah, many people do. It's a little bit confusing.
Yeah, well, it's not hard. It's just, I never used it before. You know?
Right, exactly. Okay, so in order to add a parameter, and everybody can see my flowchart, right?
Yes.
Okay, so let's pull up a function, right? If we are to click on, for example, this function, and you see this area where it says parameters, that's what we're doing. We're adding a parameter. So under first function, parameters, we would click on add. And in this case, we're just going to call it counter. Now, we don't have to put the brackets around it. Flowgorithm will do that for us. Most of them are going to be integers, so we can just leave it as an integer. Once you click OK and then OK, you'll see now you have the name of the function as well as the brackets integer counter.
Right. I did it like, I tried many times and finally like an hour I stopped. You know,
Yep. And let's do it one more time just so that everybody knows. So we'll click on this. We'll add a parameter and we'll call this one counter 2. And then once you click OK and OK, it's going to show up in the function itself.
Right. Okay.
Perfect. So I'm going to stop sharing. And again, thank you everybody for attending. I'm going to stop recording. It's going to be a great week this week. I'm excited for functions.